Okay, so welcome to another session on math and statistics for data sciences. So, in our previous two sessions, we have been looking at some of the data analysis metrics like measures of central tendency, which gave us an indication of the most typical value in a particular data set. And in our very previous session, we looked at measures of dispersion, where we looked at how basically the data is variable or how it is dispersed around the typical value, which could be a mean or a median. So if it is dispersed a lot, then the metric value for measure of dispersion would be higher, and otherwise it would be lower. Now, when we were studying the metrics for dispersion, we looked at one of the metric which was called variance. And if you guys remember, we looked at two kinds of variances. This was population variance and sample variance. Now, population variance was computed as summation of xi minus x bar whole square upon the population size, which is capital N, and the sample variance was computed as summation of xi minus x bar whole square upon small n minus 1. So small n is the sample size. Now we also had touched something on sampling, like what we saw there was, so there's a population, let us say, and let us say just to take an example, this is a set of all adults in a country. Now let us say we want to do a survey for all the adults in the country. Now clearly if we pick up all the adults in the country and take their survey, that is kind of infeasible, and it could be actually too costly to take the survey of all the adults. Apart from that, it could be very time consuming as well, because the country could have a lot of adults, and therefore to take survey of each one of them, it can be very time consuming, and finally it could be logistically unfeasible. So there could be many states in the country, and then within each state there could be many localities where there are many adults, and therefore it becomes unfeasible to actually take the survey from each adult. And this is exactly where, so to counter this situation, we do something called sampling. So in sampling, what we do, instead of taking all the adults in the whole country, what we do is we take a subset of population. So we take the subset of population to estimate or infer characteristics of the whole population. So just by taking survey of few adults, we should be able to get some idea about the whole population as well. So that is what sampling is, and we already know the reasons for sampling, because it is too costly, too time consuming, and logistically unfeasible to actually do the survey for all the population elements, and this is the reason we do the sampling process. Now what could be the benefits of sampling? So once again, benefits of sampling will directly come from reasons of sampling. Since the reason for sampling was too costly, this is less expensive, so one of the benefit would be less expensive. Since it was logistically unfeasible to take the survey for all the adults in the whole population, this becomes feasible in that sense. And then it is basically, by feasible I mean it is easier to collect and analyze. Now apart from that, since taking the survey of all the adults, it was time consuming, this can be done in a timely manner. So you can say it would be a quicker decision making process if we do sampling and we infer using sampling whatever we need to. So it's a quicker decision making process. So this is about sampling, why we do it, what are the benefits, and how we do it. So we simply take a subset of population. So in this particular example, how we can do the sampling process is we simply take a subset of a population. Now the subsetting of the population, it could be done in many ways, which would come under types of sampling, which we'll look at next. But for now you can assume that we are picking a subset of population, and this subset of population is called the sample. So this is called the sample, and we denote the population size by capital N and sample size by small n. So obviously small n is normally way less than capital N. Yeah, so this is how we do the sampling process and why we do it. Now next we would be looking at the types of sampling. So there could be many ways to pick up these adults from a particular country. So we need to see what are the different ways of sampling. So we look at it in types of sampling. Now there are two major categories of types of sampling. The first one being probability sampling, and then non-probability sampling. So in probability sampling, each member has a positive probability of being selected. So whatever methods we will see in probability sampling, we'll see that there is always a chance that each of the adult in the country can actually be selected. And in case of non-probability sampling, not every member has a known. So not every member has a known or equal chance of getting selected. And as one can expect, since all the members don't have an equal chance of selected, there is more biased behavior in non-probability sampling. So we'll see there is some bias even in probability sampling, but in general the non-probability sampling methods are more biased in terms of their selection, because they are defined that way that not all the members in the population have an equal chance of getting selected, which is the case in case of probability sampling. So now one by one we'll be looking at different methods of probability sampling, and then we'll be looking at different methods for non-probability sampling. The first probability sampling method is simple random sampling, which is perhaps the most common sampling process. So in simple random sampling, what we essentially do is each member in population has an equal chance of getting selected. So for example, let us say we are drawing a total of, let us say we have a total of population of n, and once again we are drawing a sample size of small n. So in this particular case, the probability of getting selected for each of the n capital N members in the population is given as n upon n. So since we are selecting small n from capital N, therefore the probability of selecting any of the member would be equal to small n upon capital N. So normally how we do it is we simply select, what we can do is simply we can arrange all the adults in, let's say, a particular serial number. So let us say 1, 2, 3, 4, 5, 6 and so on, and we use the random operator in either, so we can use it in any software like Python or something, and there are functions to get the random numbers generator between any to any range of values. So let us say we have a range of values. Let's say we have 100 total members in the population, and we are selecting, let's say, so n is 100, and we are selecting a sample size of 10. So we can get a sample randomly, let's say 2, 5, 10, 20, 35, 56, 79, 91, 96, and 99. So let us say this is one of the possible simple random sample from the whole population, and the only thing to note here is that each member in the population had an equal chance of getting selected. So this is how we do the simple random process, simple random sampling process, which is the first probability sampling method. Now let us look at the second probability sampling method. So we call it stratified sampling. Now let us say we have a country, and there are, let us say, 20 states. So there is a population of capital N equal to 100, and or let's say 1000, and there are 20 states in the country, and there are equal number of people in each of these 20 states. So therefore 1000 upon 20, there will be 50 people in each state. Now let us say we are taking a sample of, let us say, 40 people from 1000. So we are taking a small sample here of 40 people from 1000. Now let us say we use the SRS, or simple random sampling. So we use the simple random sampling method, and since in simple random sampling all the 1000 members would have an equal probability of getting selected, there is always a possibility that there are more number of people selected from a particular state, while there are almost negligible or none members selected from another state. So for example, let us say we have state A, B, C. Let us say we take an example of 3 states here, and the number of people in population and number of people in sample. Now we already know there are 50 people in each of the states here. So let us say we stick with that example, and we have 50 people in each of the states here. Now in simple random sampling, since we are selecting randomly, any of the members from each of the 1000 people has an equal chance of getting selected. So let's say we use the simple random sampling, and from state A we are able to select 3 people, from state B we are able to select 1, and from state C we are actually didn't get any sample, because there's always a possibility of not getting a sample from a particular state, since we are doing a simple random sampling on all the 1000 members combined. So now the problem with simple random sampling is, if we needed a sample which is representative of the whole population, the ideal way to do so would be to have a equal representation of each state in the sample as well, because there is a equal population of each state in the population. So since we had 50 people in each state, what we would want is, there should be 2 people selected from each of the 20 states, so that we have a sample size of 40, and we still have an equal representation in the sample as well for each of the state. And that is where stratified sampling comes into picture. So in case of stratified sampling, what we are essentially doing is we are dividing the population. So let us say this was the second way. So the first way was simple random sampling, and we have stratified sampling as the second way. So in this case, what we do is we have the population, which is the country, and we divide this into stratas. Stratas within the population mean that they have certain different kinds of conditions or characteristics within the population. So it is possible that different states in a country could have different cultures, and therefore different kinds of people in each of these states. So in this particular example, the strata would be the state. So each state represents a particular strata of the population. In stratified sampling, we select the sampling processes in a way that there is same proportion of people selected from a particular state which were there in the population as well. So for example, let's say we had a population size of n equal to 1000, and let us say we have state A, B, C, and the total number of people in population. So this time let us not assume that there were 50 in each of the 20 states, but let us say we had 100 in A, let us say 50 in B, and let us say we had 100 people in C as well, or let us say we have 200 in C. So we have 250 people across these three states. Now what we do is we calculate the ratio. So let us say in this particular case it would be 100 upon 1000, which is 0.1. Therefore, number of people in sample would be computed as what? 0.1 into the sample size, which is 40, therefore 4. So we need to select 4 people from state A. Now similarly, since we have 50 here, so 50 upon 1000, this will become 0.05, and therefore we will need to select 2 people from state B, and similarly 200 upon 1000, which is 0.2, and 0.2 into 40 is 8, so we need to select 8 people from state C. So what this ensures is that the proportion of people in from each state in the sample is same as the proportion distribution of these people in the population as well. So this is how we do the stratified sampling, and the main purpose of this is that it ensures that each group in the population has an equal or same representation as they have in the population as well. So this is about stratified sampling. Now the third one is called cluster sampling. So many a times people get confused between stratified sampling and cluster sampling, because cluster also sounds like we are having some clusters and we are selecting to have equal representation, but that is not exactly what is happening in cluster sampling. So in cluster sampling, what we do is we pick up a part of population. So for example, in our particular example, we select one state randomly. So we are selecting one state randomly, and then we select the sample from that state. So it is possible that after selecting one of the state, either we are selecting all the members of that state, or we can still select some random sample from that particular state. But note that why this is done is normally it is possible that for example the survey collector lives in a particular state, and he doesn't want to really travel to all the states. He would want to travel to, let's say, one state randomly and then take a sample from that particular state. So it is used in a convenience manner, but clearly it will have a weaker representation of all other states, since we are only selecting one of the state in this particular case. So basically this part of the population is nothing but it is called the cluster. So we first what we do here is actually we are dividing the population into certain clusters, and then so let us say this is A, this is B, C, D, E, and let us say we select one of the cluster randomly, so it could be E, and then from E we are selecting the sample size of N. So this is how we do the cluster sampling. So there's a very huge difference, as you can see, between the stratified sampling and cluster sampling. In stratified sampling, we need to ensure that each group has the same representation in the sample as they have in the population. While in cluster sampling, that is not the case. We are simply picking one of the cluster, and then we are doing the sampling from that particular cluster itself, and we simply ignore all other clusters. So that is how cluster sampling is done. Next, we would be looking at something called systematic sampling. So this is the fourth way of probability sampling method. And what we do is we randomly select a starting point, and then we simply pick every kth individual until a sample size n is selected. So for example, let us say we have a roll numbers of many students, and let us say these roll numbers are arranged in a particular ascending order as A, B, C, D, and so on till Z. Now let us say we are doing a systematic sampling here for k equal to 5, and the random point which we get initially, let us say, is E. So we are selecting every fifth person after E, or from E as well. We can select E as well. So let us say in this particular case, we will select E, and then the fifth person from E. So F, G, H, I, J. So J would be selected. Then the fifth person, K, L, M, N, O. So O will be selected. Then P, Q, R, S, T. So T would be selected. U, V, W, X, Y. So Y would be selected. But now let us say we wanted to select a sample size of 8. So we have just selected 5, and clearly we only have students till Z. So what we do is we simply take it in a circular manner. So after Y, what we'll do is Z, A, B, C, D. So we'll select D in this particular scenario. And once again, we continue the process. So E, F, G, H, I. So I will be selected, and then J, K, L, M, N would be the 8th person selected. So this is how we do the systematic sampling, where we start from a random point, which was E student in this particular case, and then we select the every kth student in this particular case, which is every fifth student. So even the 5 number here is randomly selected. It could be every 6th or every 7th student, it won't matter. So this is how we do the systematic sampling, which is another way of probability sampling method. Now in each of these methods, one would realize is, even though in some of these methods we are actually making some assumptions like the starting point or selecting every kth individual, we'll see that in each of these samples, before having these points selected, we still have an equal chance before the sampling process that any of the individual in the population could be selected. So that is why all these methods are called probability sampling methods. Now moving on, we would be looking at the non-probability sampling methods. So next we would be looking at non-probability sampling methods. Now here the first method is called convenience sampling. So how we do this sampling is we simply choose people that are easier to reach out to. For example, the surveyor, in our case, the example which we had, the country one. So for example, the surveyor, we have a country here, and let us say once again there are different states here. Let us say we have A, B, C, D, and E, and let us say the surveyor lives in in state C. Now since he lives in state C, he decides he doesn't want to travel, so he take survey of a few sampling adults from state C itself. Now what happens in this case, he surveyed it using his own convenience, but the problem with this is there is certain kind of a bias in his selection method, since we are missing on the other states. So there is bias here, since there is 0 probability of other states adults to be selected. So this brings in some biasness to the selection process. So here what is happening is surveyor, according to his convenience, once again is just selecting people from his own state to sample and get the survey, and therefore this is a non-probability sampling method. Next, we have something called judgmental sampling. Now what happens is here is sampling is done based on expertise of the researcher. So whoever the surveyor is, which is the researcher, in his own understanding or expertise, whatever the sampling process is required. So for example, it is possible that there is a survey which only targets certain medical practices, and therefore based on the expertise of the researcher, he would want to take a survey only for those kind of people who might have a better understanding of medical services, and therefore in this particular case all the other adults would have again not a higher, very low probability of getting selected for the survey, and therefore this is again a non-probabilistic method in that sense. So yeah, so basically these two are the most common non-probability sampling methods which we wanted to cover here. So we covered actually four probability sampling methods which are actually more used in data sciences as well in a regular manner. So out of these, simple random sampling and stratified sampling are the most common ones because they are least bias in the sampling process. Stratified sampling becomes important when you have different kinds of groups in the population and you want to have a similar representation in the sample for those groups as they have in the population as well. Then we looked at cluster sampling and systematic sampling, and finally in the non-probability sampling methods we looked at convenience sampling and judgmental sampling. So judgmental sampling sometimes is also called purposive sampling. So it's also called, since it's done for a particular purpose, like I said, therefore it is also sometimes called purposive sampling. So this is about the sampling methods which we wanted to cover here. Now one more final topic which we would be covering in this particular session is called biasness. So you can say biases in sampling. So I have been using the word bias a lot while I was explaining these different sampling methods. But what is bias? So bias occurs when a sample is not really representative of the population. So for example, once again, let us say when we were looking at convenience sampling, what we were doing was the surveyor or the researcher was only sampling people from his own state, and using the survey results for those that particular sample, he was trying to get a conclusion or inference for the whole population, which is the whole country itself, which obviously will not make sense because a particular state might not be representative of the whole country itself. As I said earlier, different states might have different cultures, and therefore one should use probability sampling methods like stratified sampling to have a better representation of each of the states in the sample. And therefore convenience sampling is actually a very biased method of getting a sample. And we had also stated earlier that non-probability methods generally have a more biased approach in making the selection. Now there could be different kinds of biases that could occur in the sampling processes, but we'll cover those in the next session. But right now just wanted to explain what bias is. So bias is something, bias can occur in a sampling process when the sample selected is not really representative of the population for which we are trying to do the sampling process.